Hello, my name is Kirtan and I'm a grade 11 student from Winnipeg, Canada. The drinking water crisis is more prevalent now than it has ever been. In 2019, the World Health Organization estimated that over 2 billion people lived in water stress conditions. Water stress can entail anything from having to travel distances to fetch drinking water, not having clean drinking water within a reasonable distance, or being forced to drink microbiologically contaminated water, and many other issues. Microbiologically contaminated water leads to over 500,000 deaths annually. So, with this project, I chose to address the issue of detecting microbiologically contaminated water. Current systems for analyzing water samples, such as centrifugation and fecal analysis, generally require expensive lab equipment and have long turnaround times. In this project, I developed a mobile phone app which uses the assistance of a paper microscope to analyze water samples and alert the user if any harmful microorganisms are found. The reason that I chose a mobile app format is because smartphones are incredibly common all across the world, even in the most remote areas, and these areas are usually the ones which are most affected by the issue of unsafe drinking water. This app utilizes deep learning. Deep learning is a process where machines and algorithms develop an artificial neural network through the process of trial and error. This app uses that artificial neural network to analyze what it is looking at through the smartphone camera and alert the user if it sees anything that it deems as unsafe. The development of this app followed four main steps: gathering the data, training the artificial neural network, integrating that artificial neural network to work on a mobile phone, and then seeing if any additional tools are needed to assist the phone in properly analyzing the water. The image data for training the neural network was mainly provided by a publicly available dataset, which contains 21 different types of microorganisms which are both harmful and non-harmful. Additional data was created through the use of data augmentation, which is where images are rotated, reflected, and zoomed to create slightly different looking images. This neural network was trained for the task of image classification, which is where an image is shown to the neural network and it tries and identifies objects that it sees within that image. To do this, the neural network needed to be fed with pre-labeled data, which, as previously mentioned, was taken from a publicly available dataset. A ResNet 50 architecture was chosen to train this neural network because it provided the best trade-off in terms of accuracy to time taken. The integration of the trained neural network onto a mobile app required it to be converted into one which could run on the relatively restrained capabilities of a mobile phone. By converting it, benefits such as lower power usage and lower computational costs were achieved, making it ideal for usage on a mobile phone. The mobile app was designed to be used in conjunction with a paper microscope because smartphone cameras simply do not have the capabilities needed, such as this one. The lens of this paper microscope is this tiny glass bead in the middle. These paper microscopes are inexpensive and can provide up to a 140 times magnification. And for this project, the paper microscope used was from Foldscope Instruments. To use this app, the user must put a water sample under the paper microscope. After holding the camera up to the paper microscope, the app takes an image and then analyzes this image to see if any harmful microorganisms are found, and then alerts the user. This form of preemptively detecting harmful microorganisms in drinking water can prevent diseases such as diarrhea and typhoid fever and can improve the lives of people living in these water stress conditions and can save lives. Thank you.